Okay, in this section we're going to be talking about velocities, and the two types are linear velocity and angular velocity. Angular velocity, as it states, is the ratio of change in the central angle to the time required for the change. And like the variable or the symbol that's used to always represent angular velocity is your Greek letter of omega. So it does look like a W, but it does kind of curve back in on the tops. So that's omega. So this is the formula that you can use to help you find the angular velocity, and that is to take your angle and divide it by t, and of course t stands for time. Now, just like with the previous section, with any of these formulas that you're working with, you have got to remember that theta has to be in radians. Okay, so if the angle is given to you in degrees, you do have to convert it to radians before you substitute that value into your formula. Okay, so what it means exactly by angular velocity, it's referring, of course, to the central angle. Okay, so this were our central angle. As something moves around the edge of the circle, a lot of times a Ferris wheel is what's used as an example, like as a person rides around the Ferris wheel, like as this person goes, say from this point around to this point, then how fast is this angle changing? Okay, so just like you're more accustomed to linear velocity, which is like something that's in miles per hour or feet per second. But instead of wanting to know how fast this person actually travels along, the edge of the Ferris wheel, how fast is the angle changing as the person moves? That's what your angular velocity is. Okay, so linear velocity, of course, as I already mentioned, is what you're more accustomed to thinking and dealing with, and that's going to be the speed of an object moving around the outside edge of the circular object. So, of course, that's what I was referencing about the person on the Ferris wheel moving around the edge. That would be linear velocity. And they use a lowercase v to represent linear velocity, and there's two different formulas that can be used to find your linear velocity. So v is equal to s over t. So s is the length of that arc, same thing that it was in previous formulas. T is time. If you're using this one, then r is your radius, and of course we've learned that the omega is your angular velocity. So we'll be using each of these formulas at different times. All right, the first several problems that I'm going to work are not, related to an actual real life situation. Just here's the numbers, plug them into the formula. So just getting you used to, like I said, working with your formulas. Okay, so in this case, you're asked to find your linear velocity. Of course, I just had the formulas up here for the linear velocity, and you have a choice, remember, of these two, the s divided by t and the r times omega, but since I've given you s and t, therefore it would make sense, obviously, to use this formula. So v is equal to s divided by t. Okay, so we know that s is 12 centimeters, and we know that t is 2 seconds. Okay, so of course the 12 divided by the 2 is going to give you 6. So what you're going to end up with is 6 centimeters per second. Okay, so linear velocity, what you're always going to have on your units, so make sure that you are putting your units as you do your homework, because I will be checking for those on the test. This is always like a linear measurement: centimeters, meters, feet, inches, yards, miles, and then it's per unit of time. So, seconds, minutes, hours. So this is always the type of units that you'll see on linear velocity. Okay, next. Okay, this time you're asked to find S, and you're given V, and you're given T. So actually we're going to use the same formula that we used just a minute ago, which was the V is equal to S over T. Now you can substitute your information in right now, but if you choose to do so, you could go ahead, take the formula and get S on one side by itself, since S is what you're trying to find. So if I wanted to isolate the S, then I'm going to have to multiply both sides by T. So I would have S is equal to V times T. Okay, so now let's substitute in. So for V, I have 63 miles per hour. 63 miles per hour. Now I always write my units like this because you'll see actually on this example and on several others, sometimes you have to do conversions with your units, so I like to just have it written in that fraction form. And we're going to multiply this times T, which is 10 seconds. Now the reason why you have to do some conversions here is because you don't have the same time units. This is hours and this is seconds, okay? And actually, if you're finding S, if you remember, S is the distance around the edge of the circle. So it's not a velocity, like you're not going to have units that are something per something. S is going to be just inches or just yards or just meters or just miles, okay? So think about what you're trying to find and what kind of units you should expect to have. So since this is given to me with miles, actually that's what S is going to come out to be, is just so many miles. So I actually need to get my hours and my seconds to both cancel out. So I'm going to put this over 1, and I'm going to write a conversion here between seconds and hours. So you need to ask yourself, how many seconds are there in 1 hour? Okay, now seconds in an hour would require 60 times 60, because there's 60 seconds in a minute and then 60 minutes in an hour. So 1 hour contains 3,600 seconds. Now you're going to want to put the 1 hour on the top and the 3,600 seconds on the bottom. And the reason why you want to do it in that order is if you're needing your times to cancel out, you've got to have your hours, where one of them's in the numerator and one's in the denominator, so they will get those to cancel. And the same thing that you're seeing here, you're going to get your seconds to cancel out, okay? All right, so these cancel. These cancel. Now you can just use your calculator at this point. Just do your 63 times your 10, and then divide that by the 3,600, and that's going to come out to be 0.175. And of course the only units that I have left up here is the miles. So this would be my answer. But S is just a distance. It's just a length, okay? So it's not going to have like, the slash, like something per something in an answer for that. Okay, next. Okay, so this time we're asked to find the angular velocity, and you're given theta and you're given t. All right, so if you look at your formulas, you have omega is equal to theta divided by t. Okay, so anytime you're dealing with theta, remember theta has to be in radians. Now, since there's not a degree symbol on the 24, that means it is understood to be in radians. Therefore, you can substitute in the 24. There's nothing you have to change there. And I'm going to go ahead and put the RAD there to stand for radians, because we have to be aware, remember, of our units, what we're dealing with there. Okay, and time is 6 minutes. So 24 divided by 6 is going to give me 4. I've got radians left on the top, minutes on the bottom. So this is going to be radians per minute. Now remember, omega is an angular velocity. Okay, so since it's a velocity, you will have units that are something per something. Okay, so the way it's always going to be with angular is this is going to be radians. And that's because, remember, angular velocity is talking about how fast the angle is changing. Okay, so if you're talking about how fast the angle is changing, that's why you have radians here. And then this will be a unit of time. Again, like, seconds or minutes or hours. Okay, so this is the type of units you can expect to see anytime you're asked to find omega.